Our current interpreter can raise exceptions in a variety of situations. For example, when we have an expression that applies a number to some other argument, then we expect the interpreter to raise the exception, not a function. Plait supports those exceptions, and it provides a test exn form that we can use to check that a call to the interpreter raises an exception. So Plait's exceptions have been handy, but this is another thing that we would like to take control of ourselves. So we're going to start by changing in our interpreter so that it doesn't raise exceptions, but instead returns error v, a kind of pseudo value, when it encounters an exception. So in this case, where we tried to apply the number 1 like a function, then we should expect error v, not a function back, instead of an exception. And so we test it with the test form instead. And everywhere where we use to raise error, call error to raise an exception, then we're going to produce an error v value instead. So let's go see what this looks like in the implementation. I've got numv and close v. I'm going to add error v, where the field is a string. And then I'm going to look for all calls to error that I might want to change. So we won't worry about the parser. We're interested in the interpreter. But here's an interpreter case. That's the not a function case. So instead of calling the error function, we want to construct an error v value now. And here in num plus and num times, where we had not a number, we want it to be error v. And finally in lookup, we want to produce an error v. So that's all our calls to error v. We need to also change all the places where we had test exn to catch those exceptions. Again, we don't care about the parser. But here's one for the interpreter. Now instead of an exception, we expect an error v result back. Actually, this one's going to be big enough that we'll delay for a little while. So with those changes, we can try running our program, see if the tests pass. And all of the tests that we have right now do pass. We can also experiment a little bit. We can check that interp of parse of x in the empty environment with the done continuation will produce a free variable error. How about if we have +1 of that x? Again, this should be a free variable, but what we get instead is not a number. Why does that happen? Well, we know how the interpreter works. It's going to start interpreting the 1, that'll be fine. It'll start interpreting the x, and that's where it gets an error v, returned as a result from lookup. So when we call lookup, it'll have error v there, and that call is up in interp. And the result of lookup is then passed on to continue. But that's exactly our problem. When lookup fails, we don't want to continue. The way to solve this problem is, well, we could check the result of lookup to see whether it's an error v, but a better way to solve the problem is whenever you have something that might fail, that might return an error v, pass along the continuation so that that function can decide whether to continue or not. So now we're going to go down to lookup, and we'll change it to take an extra continuation argument. And we'll pass it in the recursive calls here. When we want to return an error v, we won't continue with k. When we do have a value to return, in that case we will continue with k. Now all we have to do is fix up our tests because lookup now wants a continuation. And see how it does. Let's see, I missed one, or I put it in the wrong place. All of those things pass. Our new example passes. We get a free variable error instead of not a number error. Let's turn this into a test. So let's put it up here with our other interp tests. So in this case, we want to fail with free variable. And then that new test will still pass. Good. We could run it again down here. We could also take this x. What if we change it to lambda x dot x? In that case, it's not a free variable anymore. That's where we should still get not a number. Let's try one more example. Let's take this addition expression and put it as an application to 8. So we still expect the not a number error because that should happen first. But what's going to happen here is that the error v from this +1 of a function is going to try to be used as a function applied to 8, and so we get not a function out. So there again, we're continuing where we don't want to continue. In this case, it happens because we call num plus and num times, they're the ones that fail with error v, and so following our strategy before, what we should do is take this continuation and pass it to those functions instead, so they can decide whether to continue or not. So there and here. Now I need to change num plus and num times. They will each take a continuation argument, and they will each pass that along to our num_up function, which now will need a continuation argument. And when num_up succeeds, then it should succeed by continuing, and when it does not succeed, then it should raise error v by not continuing. Again, we need to update our tests here, and let's also add a direct test that if we do num star of num v1, close vx, IDE x in the empty environment, that and give it an empty continuation. Oops, done continuations, not values. Then we should get an error v, not a number. So those should work, and the example we tried before should also work with not a number. So let's turn this again into a test case. And the new test passes. So just to review what we did, we changed calls from error to error v, and we changed functions like lookup that want to return an error v to take a continuation argument. And that way the continuation argument can be used with continue when the function wants to return a normal value. Otherwise it returns error v without continuing to return an error value. And the same thing happens in num_up, just like lookup.